Hello everyone. In this video I'm going to show you a numerical technique for doing integration. That is for finding the areas under a curve without using rectangles. We're going to use trapezoids. So it's called the trapezoidal rule. So that's what I'm going to show you how to do in this video. Now, first of all, before we can do this, we need to remember, how do you find the area of a trapezoid? Well, a trapezoid is a shape that looks like the picture I have here. You have two sides that are parallel. Y naught is the length of one side, and y sub 1 is the length of the other side, and then you have the height. So the area of a trapezoid is half of the sum of the two parallel sides multiplied by the height. We are going to use that to figure out, as part of what we're going to do to find the area under a curve using the trapezoidal rule. So suppose we have a curve like this, and this curve has equation y equals to f of x, and we want to find the area under the curve from point A to point B, x equals to A to x equals to B. So what we are going to do is starting from the initial point x equals to A, we are going to draw in so many trapezoids in there. Sometimes you use 2 trapezoids or 3 trapezoids or 4 trapezoids. But from the last lesson we discussed, you would see that you will remember that the more shape you use, like it was rectangles back then, now it's going to be trapezoids. The more trapezoids you use, the better your approximation is going to be for the area under the curve. Okay, so you divide the area, the distance from A to B, into so many equal width trapezoids, and then you will find the area of the trapezoids and add them all together. So starting from the beginning, from the initial point, we'll call that x sub 0, that will be A, and then x sub 1 and x sub 2, x sub 3, and so on. And the distance between each of the x's is going to be the same, because that's going to be your h. Okay, and their corresponding height, as corresponding parallel sides, for the first trapezoid is y sub 0 and y sub 1. For the second trapezoid is y sub 1 and y sub 2, and so on. So, given that the area of a trapezoid is what I showed you before, so to find the area under the curve from A to B, we'll just find the area of each of the trapezoids, and it will give us an approximation. So for the first trapezoid, the area is half of y sub 0 plus y sub 1 multiplied by h, plus half of y sub 1 plus y sub 2 multiplied by h, plus half of y sub 2 plus y sub 3 multiplied by h, and so on, all the way to half of y sub n minus 1 plus y sub n multiplied by h, which, if you rewrite, if you factor out the h over 2, the half and the h, and you deal with what's inside, you will come up with an equation that looks like this: h over 2 multiplied by y sub 0 plus 2 times y sub 1 plus 2 times y sub 2, and so on, all the way to y sub n. This is the area under the curve when you're talking about the trapezoidal rule, where y sub 0 is f of x sub 0. So for each of the x's you have on the x-axis, you would have the corresponding y value. Y sub 1 is f of x sub 1, y sub 2 is f of x sub 2, and so on. And h is b minus a divided by n. H is the height of each of the trapezoids. Okay, I'm going to go back here. Where is h? H is right here. This is h right there. Okay, that's h. So, and it's b minus a divided by n. So for example, let's see a couple examples. Let's see this first one. We want to approximate the value of the integral of 1 over x from 1 to 3 dx by the trapezoidal rule. Let n equal 4. So we are using 4 trapezoids to figure out the area under this curve. Now, you don't necessarily need to draw a curve, but it helps to see what you are actually doing. 1 over x is this curve. Now, on the side where we need it is from 1 to 3, so it's only in the first quadrant of the Cartesian coordinate plane, right? So the curve is this blue line I drew in here, and it's going from 1 to 3. We want to use the trapezoidal rule to figure that out. So we're going to be using 4 trapezoids, which if we draw in there, you can see, starting from the initial point 1 all the way to 3, we're going to draw in 4 trapezoids in there. And we're going to figure out what the h is, the height of each of the trapezoids, as well as their parallel sides. Okay, so if we're going to do this, first of all, our formula that we are using, our formula that we are using is a sub t, which is h over 2 multiplied by y sub 0 plus 2 times y sub 1 plus 2 times y sub 2 plus 2 times y sub 3 plus y sub 4. And we said that h is b minus a over n. In this case, b is 3, that's the end point, and the initial point is 1. So 3 minus 1 divided by 4, that's 2 over 4, which is 1/2. Okay, and then starting from the initial point, x sub 0 is 1, that's the initial point. The next point, x sub 1, will be 1 plus h, 1 plus 0.5, that's 1.5, that's 3 over 2, that's what you have over here. And then x sub 2 is 1.5 plus half, that's 2. X sub 3 is 2 plus 2.5, 2 plus 1/2, that's 2.5. And finally, x sub 4, which is the last point, is 2.5 plus half, that's 3. So that's how I came about all these points in here. And then we need to figure out their corresponding y values. So these are all the x values. Their corresponding y values we can calculate. Since the function is y equals to f of x, which is 1 over x, so if x sub 0 is 1, y sub 0 is f of 1, which is 1 over 1, that's equal to 1. Y sub 1 is f of x sub 1. X sub 1 is 3 over 2, so f of 3 over 2, that's the reciprocal of 3 over 2, that's 2/3. And then, same thing for y sub 2, that is f of 2, because x2 is equal to 2, that's equal to 1/2. And then for y3, that is f of x3, that's f of 2.5, so that's f of 5 over 2, that's 2/5. And finally, y4 is f of x4, which will be 1/3. So using our trapezoidal formula for this example, you can see that you are using 4 trapezoids. Okay, so you're going to have 5 y values in there, like I've shown you in here. If you're having 3 trapezoids, you will have 4 y values. In this case, we have 4 trapezoids, we have 5 y values, according to the picture I drew you before. And we already figured out all the things we need in here, so all we have to do is just substitute them in here. H over 2, h is 1/2, we are dividing that by 2, and then into the bracket, y sub 0 is equal to 1, plus 2 times y sub 1, right, that's 2 times 2/3, plus 2 times y sub 2, that's 2 times 1/2, plus 2 times y sub 3, that's 2 times 2/5, plus y sub 4, which is 1/3. So all we're doing now is just arithmetic, right? Half divided by 2 is a quarter, times 1 plus 2 times 2/3 is 4/3, then plus 2 times 1/2, that is 1, plus 2 times 2/5, that's 4/5, plus 1/3, which if you simplify, you will just get 67 over 60 squared units will be the area under the curve, the approximate area under the curve using the trapezoidal rule. If you are using 4 trapezoids, that is. Let me do another example with you. So another example I'm going to show you here. Approximate the value. Did you want to do like that? Okay. So for this next example, it is to approximate the value of the integral by using the trapezoidal rule. The integral is given as the integral is 1 minus x squared dx from 0 to 1, and we're using n equals to 3. So in the picture we have here, first of all, you can see I drew a picture here for the curve 1 minus x squared. The picture of that looks like what we have over here. It's a parabola. The leading coefficient is negative, so it faces downward. And the area you want is in the first quadrant, from 0 to 1. Okay. So the formula we're using for the area of a trapezoid is what I have over here. All right. So that is from a sub t equals to half of h, which is the same thing as h over 2, multiplied into y sub 0 plus 2 times y sub 1 plus 2 times y sub 2 plus y sub 3. H is b minus a divided by n, as in the previous example. B in this case is 1, a is 0, so 1 minus 0 divided by 3, so that's 1/3. Therefore, x sub 0, which is from the beginning, right, the initial point is x sub 0, x sub 0 is over there, right, x sub 0 is here, which is equal to 0, and then x sub 1 is going to be 1/3, right, 0 plus h is 1/3, and then x sub 2, similarly, 1/3 plus 1/3, that's 2/3, and x sub 3 is 1/3 plus 2/3, that will be 1. So those are all the four points you have in there, and then we can find the corresponding y values. So y sub 0 is f of x sub 0, which is f of 0, right? According to our function that we are using, the function we are using is 1 minus x squared. So that's 1 minus 0 squared, which is equal to 1. And then y1 is f of x1, that is f of 1/3, okay, which is 1 minus 1/3 squared. That's 8 over 9. And then f of x2, that's f of 2/3. That's 1 minus 2/3 squared. That's 5 over 9. And finally, y sub 3 is f of x3, that's f of 1. 1 minus 1 squared, that's equal to 0. So therefore, excuse me, the area under the curve using the trapezoidal rule in this example, according to a formula that we've written here, half h or h over 2 times y sub 0 plus 2y1 plus 2y2 plus y3 will equal, given that h is 1/3, will be half times 1/3 times 1 plus 2 times 8 over 9 plus 2 times 5 over 9 plus 0, which if you simplify just arithmetic there, your result will be 35 over 54 will be your result there. So why don't you try one example by yourself? So I have an example here for you to try. Like in my previous video, what you should do now is you should pause this video and try this example. And when you are finished, you can continue the video to see what I have done. So please pause the video now. Alright, so what did you do? I'll show you what I did. Okay, sorry, just give me one sec. Alright, sorry about that. So here is what I did. First of all, I drew the curve, okay, 2x, y equals to 2x squared. So that curve looks something like that. And the area you want is from 0 to 2. And according to the question, we are supposed to use 4 trapezoids. So the formula for the area under the curve is what we have over there right now. A sub t is h over 2 times y sub 0 plus 2y1 plus 2y2 plus 2y3 plus 2y4. You are using 4 trapezoids, so you are going to have 5 y values, as I've shown you over here. H is b minus a divided by 2, b is 2, a is 0, and n is 4. So your h is going to be 1/2. So now we can split up from a to b, and all our x values are as shown, right? From 0 to 1/2, then 1/2 plus 1/2 is 1. 1 plus 1/2 is 3.5. 3.5 plus 1/2 is 2. Those are all the x values. And then we need to figure out their corresponding y values using our function that we have been given, which is f of x is 2x squared. So if x sub 0 is 0, y sub 0 is 2 times 0 squared, which is 0. And then x1 is 1/2. That will be y0 will give you 2 times 1/2 squared, which is 1/2. X sub 2 is 1. So y sub 2 is 2 times 1 squared, which is 2. X sub 3 is 3/2. Y2 is 2 times 3/2 squared, which is 9/2. And finally, x4 is 2, and y4 is 2 times 2 squared, which is 8. So now we have all that information. We can just put them in our formula that we have, and have the area under the curve is h over 2, which is half over 2, multiplied into the brackets. Y sub 0 is 0, y sub 1 is 1/2, so that's 2 times 1/2, plus 2 times y2, that's 2 times 2, plus 2 times y3, which is 2 times 9/2, and finally plus y4. So which, if we simplify, we're just doing some arithmetic there, your result will be 11/2. I hope that's what you obtained, and I hope this is clear to you. I have some homework for you for practice, so I took a picture of it and I put it here for you. I hope you can see it. It's exercise 25.5, and it's numbers 7, 9, 11, and 13 from your textbook. So try your hands on this, and when we meet over in the next couple of days, if you have any questions, we can discuss those things. Okay, so that is the end of chapter 25.